Hello and welcome back to another video. Here we are going to solve the last 5 questions from November 2020 970932, that is pure mathematics 3. So we have already solved the first 5 questions in the previous video. So here is the question number 6. The complex number u is defined by u is equal to 7 plus iota over 1 minus iota. Express u in the form of x plus iota y, where x and y are real. So we know that whenever we have a division form, we are going to rationalize it with by multiplying and dividing by the complex conjugate of the denominator. And for complex conjugate, for any a plus iota b, the complex conjugate is going to be a minus iota b. So here we can write u as 7 plus iota over 1 minus iota multiplied by 1 plus iota over 1 plus iota. So since we know that iota square is minus 1, and here it is in the denominator we have a minus b, a plus b, that will give you a square plus b square, a square minus b square. So it becomes 1 square minus iota square over this, in the numerator it is product of these two complex number, that is 7 into 1 is 7, iota into iota is minus 1, 7 into iota is 7 iota, 1 into iota is iota. So altogether we got 6 plus 8 iota over 1 minus, and this iota square is minus 1, so it becomes plus 1. So altogether we got u as 6 plus 8 by 2, so it means 3 plus 4 iota. It means x is 3 and y is 4. I hope it is clear. Let's do the second part, B part of it. Here is the B part. Show on a sketch of an Argand diagram the points A, B, C representing u, 7 plus iota and 1 minus iota respectively. So I have included this box here so that it would be easy for me to draw it. So let me draw the axis. So here the axis, this one is real axis and this one is imaginary axis, and now we will mark A, B and C. Since A is u and we got u as 3 plus 4 iota from the previous part, so 1 2 3 1 2 3 4, so this point is A. Next is 7 plus iota. 7 plus iota means real part are 7, 1 2 3 4 5 6 7, and imaginary 1 1, so this is going to be B. And for C it is 1 minus iota. Imaginary and real both are 1 and imaginary is minus 1, so it would be 1 and minus 1 in below, so it becomes C. So these are the points. We only need to sketch the points A, B, C. So these are the points A, B, C. Let's do the C part. Here's the C part. By considering the arguments of 7 plus iota and 1 minus iota, show that tangent inverse of 4 over 3 is equal to tangent inverse of 1 over 7 plus 1/4 of pi. So we know from the first part that u is equal to 7 plus iota over 1 minus iota, and we have simplified and it was completely as 3 plus 4 iota. Now if we use the property that argument of a upon b is two complex number, it is going to be argument of a minus argument of b. So that is what we are going to use here. So we have argument of complex number 3 plus 4 iota is equal to argument of 7 plus iota over 1 minus iota, and they have told that we need to use the argument of 7 plus iota and 1 minus iota, so it becomes argument of 7 plus iota minus argument of 1 minus iota. And we know for any complex number z, x plus iota y, the argument of z is tangent inverse of y by x, so that's why we got tangent inverse of 4 by 3 from here, and right side we have tangent inverse of 1 upon 7 minus tangent inverse of minus 1 upon 1, that is minus 1. And we know this 1 comma minus 1 comma 1 minus iota lies here, so this argument will be minus pi by 4. So that's why we got tangent inverse of 4 by 3 is equal to tangent inverse 1 over 7 and minus minus plus 1/4 of pi. That is what we need to prove. So that was the question number 6c part. And here is the question number 7. The variables x and t satisfy the differential equation e raised to the power 3t into dx over dt is equal to cos square 2x for t greater than equal to 0. It is given that x is equal to 0 when t is equal to 0. This is the condition so that we can get rid of the constant of integration. A part is solve the differential equation and obtain an expression for x in terms of t. So first task is to solve the differential equation, and we know we have t and x both, so we are going to use the variable separable method here. So we'll do the integration of, I'll take this cos square 2x into the other left hand side, and it will become 1 upon cos square 2x dx, and dt and e raised to the power t to the other side, and it become dt over e raised to the power 3t and plus constant of integration. Now let's integrate it. So it will become, one more time I'll write, it is going to be sec square 2x dx is equal to e raised to the power minus 3t dt plus c. We could have written this c afterward after integration, but that's fine, is equal to, now we know that differentiation of ddx of tan x is sec square x, so integration of sec square x would be tan x, so it will become tan, and here in the case of this it is 2x, so it would be tan 2x, and upon the differentiation of this, and that is going to be 2, is equal to, again in the same way, differentiation of integration of e raised to the power minus 3t would be minus 3 e raised to the power minus 3t, and divide by the differentiation of this, and that is minus 3 plus constant of integration. Now we'll put x is equal to 0 when t is equal to 0, and we'll get tan 0, which is 0, is equal to e raised to the power 0, that is 1 over minus 3 plus c, and hence we got c as 1 over 3. We'll transfer it to the other side, and hence we got the solution of it in form of x and t. 1 by 2 tan 2x is equal to minus 1 upon 3 e raised to the power 3t plus 1 by 3. Now the next part is to obtain an expression for x in terms of t. So let's collect them, let's arrange them so that we can get x one side. So we have tan 2x here, and here it is 3t and all, so we can write this, I'll take 1 upon 3 common, and it become minus e raised to the power 3t plus 1, and we can write tan 2x is equal to 1 upon 3 into 2, because this goes that side, 2 into 1 upon 3, and I'll write 1 minus e raised to the power minus 3t, sorry it is minus 3t. So now 2x would be tangent inverse, because we require this x is given as the form of angle, so tan inverse of this all, because 2 by 3 into, sorry it is 2 by 3, 1 minus e raised to the power minus 3t, and hence x in form in the terms of t would be 1 upon 2 tan inverse 2 by 3 times 1 minus e raised to the power minus 3t, this, and that's the answer. Let's do the second part of this question. Here's the B part. State what happens to the value of x when t tends to infinity. So we know that when t tends to infinity, e raised to the power minus 3t would tends to 0, because it is 1 upon e raised to the power 3t, which will tends to 1 upon infinity, and that is which will tends to 0, and hence I will write the things which we got from the A part. Here we got from the A part x is equal to this, So when t tends to infinity, this tends to 0, and hence we got x value will as 1 upon 2 tan inverse of 2 by 3 only. So that's the answer. Let's do the next question. Here's the question number 8. With respect to the origin O, the position vectors of points A, B, C and D are given as this. So show that the first part is show that AB is equal to 2 times of CD. AB means length of AB, that is modulus of vector AB, and here modulus of vector CD. So first of all we require to find the AB vector and CD vector, then we'll find their magnitude, which will be AB and CD respectively. And AB vector is going to be B vector minus, that is OB vector minus OA vector. So we are going to subtract their corresponding values. So OB is 4 minus 1 1 and OA is 2 1 5. So 4 minus 2 is 2, minus 1 is minus 2, and 1 minus 5 is minus 4. So AB vector is 2 minus 2 minus 4, and CD vector is going to be OD vector minus OC vector. That's now again we'll subtract OD minus OC, 3 minus 1 2, 2 minus 1 1, 3 minus 2 1. So now we'll calculate AB and CD. Modulus of that, AB modulus is going to be square root of 2 square plus 2 minus 2 square, that is 4 again, and then 4 4 is 16, so it becomes 24, and 24 can be written as 6 4 is 24, so 2 root 6, and modulus of CD, which is CD only, this is going to be 2 square 4 plus 1 plus 1, that is root 6. So from here we can see modulus of AB is equal to 2 times of root 6, and root 6 is modulus of CD, and hence AB is equal to 2 times of CD. So I hope it is clear. Let's do the second one. Find the angle between the directions of AB and CD. Directions between AB and CD, we can take it as with the help of dot product. AB vector dot CD vector is equal to modulus of AB into modulus of CD and cos of angle between them, let's say it is theta. So from the first part, AB dot CD means AB was, I'll write AB vector. From the previous part it was 2 minus 2 minus 4, and CD vector was 2 1 1. And now dot product means multiplying these two, so 2 into 2 4 plus minus 2 into 1 minus 2, so I like minus 2, and minus 4 into minus 1, that is minus 4, no sorry, minus 4 into 1 minus 4 is equal to modulus of AB, we know it is root 2 root 6, modulus of CD is root 6, and cos of theta, so it become minus 2. You can see these two will be cancelled. So from here cos theta is going to be minus 2 over 2 into 6, become 1 over 6, and hence theta is going to be cos inverse. Hence we will get theta, the angle between them is going to be cos it is minus 1 by 6, cos inverse of minus 1 by 6, and which is going to be 99.59, that is 99.6 degree in degree. Now this is the answer from the calculator. So that is the angle between the directions of AB and CD. Here's the C part. Show that the line through A and B does not intersect the line through C and D. So if A and B are the 2 points and this is a line in this passing through this, it would be R is equal to let's say if it is A plus T times B vector, this is OA, and plus direction vector, this vector is B. Similarly for C and D, and direction vector is D, then it would be we can take T plus C vector, and then R vector is this. this is the line, these are the two lines, B and D are the direction vectors. And here in this case we will take the direction vectors as AB vector, and in this way it is going to be CD vector, because CD vector is in this directions only. So the equation of line through AB, it is going to be R vector is equal to any point A and B. I'll take A, and here A is 215, so it becomes 2I cap plus J cap plus 5K cap plus lambda times any scalar quantity, lambda times the direction, and AB was 2 minus 2 minus 4, so it is 2I cap minus 2J cap minus 4K cap. Similarly for line through C and D, I can take it as R vector as C is 1 1 2, that is I cap plus J cap plus 2K cap plus lambda, as lambda here will take mu times the direction vector, that is CD vector, and CD vector was 2 1 1, so it becomes 2I cap plus J cap plus K cap. Now if these two lines intersect, it means for some values of lambda and mu, a fixed value of lambda and fixed value of mu, that would be true for all the three components I, J and K. So we'll equate them first of all, and that is going to be equating them in this, I'm writing this with the I, J, K component. It would be 2 plus 2 lambda, it is lambda, 2 plus 2 lambda I cap plus 1 minus 2 lambda J cap plus 5 minus 4 lambda K cap is equal to, for this we get 1 plus 2 mu I cap plus 1 plus mu J cap, and the last one is 2 plus mu K cap. So now if we'll equate their coefficients, we will get 2 plus 2 lambda is equal to 1 plus 2 mu, 1 minus 2 lambda is equal to 1 plus mu, and the last one 5 minus 4 lambda is equal to 2 plus mu. Now we'll find the lambda and mu from any of the two equations, and we'll check whether it satisfies the third one or not. So I will take the last two equations, this and this, to find the lambda and mu, and we can see if we subtract the second equation from the third, or third equation from the second, we will get 1 minus 5, that is going to be minus 4, and minus 2 lambda minus plus 4 lambda become plus 2 lambda, and 1 minus 2 is going to be minus 1, and lambda mu minus mu is 0. So we got this as 2 lambda is equal to 2 lambda, we will get it as this minus 4 will come here, so it becomes 3. That's why the lambda become 3 by 2. Now we will find the mu. So we can get the mu from any of the two equations. I'll take the second one, and I'll put lambda as 3 by 2, and that is going to be 1 minus 2 into 3 by 2, that is 3 is equal to 1 plus mu, 1 cancel, and from here directly we can see that mu is going to be minus 3. Now we have two values, those are lambda is equal to 3 by 2 and mu is equal to minus 3 by 2. If these two values satisfy the first equation, then we will say that they intersect, otherwise they will not intersect. So from here 2 plus 2 lambda, the left hand side, 2 plus 2 lambda is equal to 2 plus 2 into 3 by 2 cancelled, and we got 5. Now right hand side is equal to 1 plus 2 mu, that is 1 plus 2 times minus 3, so it is minus 5. So since 2 plus 2 lambda is not equal to 1 plus 2 mu for this value, hence they don't intersect. They do not intersect. So I hope it is clear. Let's do the next question. And here's the question number 9. Let fx is equal to 7x plus 18 over 3x plus 2 times x square plus 4. Express fx in partial fractions. So since in the denominator we have one linear factor and one quadratic, so we will write fx, that is 7x plus 18, 7x plus 18 over 3x plus 2 into x square plus 4 as a over 3x plus 2 because it's linear, and plus bx plus c because the denominator, the second term, is quadratic, so the numerator should be linear, so it is x square plus 4 here. Now we will multiply the whole equation by the denominator, so we will get it as 7x plus 18. Here it would be x square plus 4 because it is already 3x plus 2, and here it is x square plus 4 is there in the denominator, so only we will be left with 3x plus 2 because these two will be cancelled. Now we'll find the a, b and c by since this is true for all x, so we can put any value of x. I'll put x is equal to, first in order to make this as 0 I need to put x is equal to minus 2 by 3 because 3x plus 2 is equal to 0 and x is equal to minus 2 by 3, so it become minus, at x is equal to minus 2 by 3 we will get this as minus 14 over 3 plus 18 is equal to, here this is 0, the first term is x square, so minus is minus 2 square 4 over 3, the square is 9, so 4 over 9, and here it is 9 4 is 36, so it becomes 40 over 9a. So we'll solve this, and we know minus, now we'll calculate this minus 14 over 3 plus 18. This is going to be 40 over 3, and right hand side is 40 over 9a, so we'll cancel and we'll get a value as 3. Now we can put any value for the next one because we cannot get this 0, so x will put it as 0 first of all, then it become 18 is equal to, this is 4a, and here it is, this is 0, bx means b times 0, then 3 times 2 c into 2, that is going to be 2c. Is it, this now will be 18 is equal to, a is 3, so it 4 3 is 12 plus 2c, and hence it become 12 minus 18 minus 12 6 divided by 2 is 3, so c is equal to 6 divided by 2, that is 3. And now we'll put x is equal to 1. We can put x is equal to minus 1, minus 2, anything, but I'll put x equal to 1 here so that it will be simplified. 18 plus 7 is 25. 18 plus 7 is 25 is equal to a, x is 1, so 5 times a, plus this is 1 now, so b plus c, and 3 plus 2 5, so 5 times b plus c. Now we'll replace the value of substitute the values of a and c. We'll get 25 is equal to 5 3s are 15 plus 3 5 3s are 15, and this is 5, so 5b plus 15 means we'll solve b is equal to, this is 25, this is 30, minus 5, so minus 1. So b is equal to minus 1. Hence this fx can be written as, I'll write fx as, now I'm going to substitute the values of a, b and c, then it become 3 over 3x plus 2. I'll write minus here so that I can write it as x minus 3, because it would be minus x plus 3, so I took minus common, so it become x minus 3 upon x square plus 4. That is a partial fraction. I hope it is clear. Let's do the b part. Here's the b part. Hence find the exact value. Hence find means we are going to replace fx by the previous values, value of this. So from the previous value we know that fx is equal to fx is equal to 3 over 3x plus 2 minus x minus 3 over x square plus 4. Now in order to integrate this, means we are integrating all the parts from 0 to 2, 0 to 2, 0 to 2, and here it is dx, dx and dx. Now we'll simply integrate this, and we can rewrite it as 3 times 0 to 2, 1 over 3x plus 2 dx. I'll separate this, and it would become minus 0 to 2 x over x square plus 4 minus minus plus 3 times 3, it is 1 over x square plus 4, and we'll write 4 as 2 square dx. Now it is this is simply ln modulus, no need to apply the modulus because in between 0 and 2 it is always positive. So 3x plus 2 divide by the differentiation of this, that is 3, minus, it is if I multiply and divide by 2, the differentiation of x square plus 4 would be 2x, which is already here, so we can also write this as ln of x square plus 4. And here it is x 1 upon a x square plus a square, that is tangent inverse, so it becomes 3 into 1 upon 2 tan inverse of x upon 2. Now we will put the limit, but before that we'll simplify it further. 0 to 2, it is also 0 to 2, 3 cancelled, and this 3 by 2, so we got it as ln 3x plus 2, and this is root 1 by 2, so we can transfer it in the multiplication, so it become root x square plus 4. We have used the property log n log a can be written as log a power n, so it becomes this plus 3 by 2 tangent inverse x by 2. Let's put the limits here now. If we put the upper, this will be by upper limit 2, 3 to just 6 plus 2 8, and it is also 8 but root 8, so it become ln 8 over root 8 plus it is 3 by 2, 3 by 2 and tangent inverse 2 by 2, that is 1, so it become pi by 4 minus the lower limit is 0, so this is 0, this is 0, so 2 by root 4, that is 2, so it become ln 2 by 2, that is 1. Now we will simplify it, it become ln, and we know that if it is 8 upon root 8, we can write 8 as root 8 into root 8 upon root 8, we can cancel this and we will get root 8, so it is root 8 plus 3 by 8 times pi, and root 8 we can write 3 power 3, 2 raised to the power 3, so it become ln 2 raised to the power 3 by 2 plus 3 by 2 3 by 2 8 pi, and it is going to be 3 by 2 ln 2 plus 3 by 8 pi, and that's the answer, that's the value of this, exact value of this. Here is the question number 10. The diagram shows the curve y is equal to root x cos x from in between 0 to 3 by 2 pi. It is its maximum point m here, it is minimum point m, where x is equal to a. The shaded region between the curve and the x-axis is denoted by r. Now the first part is to show that a satisfies the equation tan a is equal to 1 over 2a. So since we know that m is the minimum point, so for minimum or maximum point we require dy over dx, and we will make it equal to 0 to get the value where it is minimum. So dy over dx for this, and since it is a product of two functions, so we'll use the product rule, and the first function cos root x, second function's differentiation is going to be minus sine x, plus first function as it is, second function as it is, differentiation of second function, that is going to be 1 upon 2 root x. And for at x is equal to a, dy over dx should be 0, means minus root a sine x plus 1 upon 2 root a cos x, sorry, cos a is equal to 0, or we will transfer it to the other side. 1 upon 2 root a cos a is equal to root a sine a, and hence we will take it here to it becomes 1 upon 2a, root a into root a is a, and here sine upon cos is tan a, and hence that is what we need to show, because a satisfies this equation. I hope it is clear. Let's do the B part. Here's the B part. The sequence of values given by iterative formula an plus 1 is equal to pi plus tangent inverse of 1 upon 2 an with initial value x1 as 3 converts to a. Use this formula to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So we are going to use the calculator in this case, and first thing is we are going to fix the value of answer as 3 as the initial value, so that we can find the next value easily just by pressing the equality button. So a2 would be pi plus tan inverse 1 upon 2a1, and a1 is here as 3, so it is going to be 3, and we'll put it as it is in the calculator. In place of 3 we'll put answer, because answer key is having value 3, and this value is 3.3067 and so on, and we need to write only 4 decimal places, so till this is fine. And a3 just by pressing the equality button we get 3.29166 and so on. a4 again, a4 is 3.2923 and so on, and a5 is 3.292308 and all. So we can see the till 2 decimal places the correct answer of a is going to be 3.29, and that's the answer. Let's do the last question of this paper. Here's the C part. Find the volume of solid obtained when the region R is rotated completely about the x-axis. Completely means 360 degree about the x-axis. Give your answer in terms of pi. So let me bring the diagram here first of all. Here's the diagram. In order to find the volume of the solid, we require the limits to integrate. This is 0, and we need to find this value. And we know that at this place, this y, which is root x cos x, then at this point it should be 0, means root x is 0 or cos x is 0. Root x means x is 0, which we have already. For the next value we should get cos x is equal to 0, and for that case x should be pi over 2. Now we need to find the volume. So volume would be pi limits from 0 to pi by 2 pi y square dx, and if y is equal to root x cos x, so y square would be, I'll write pi 0 to pi by 2 x cos square x dx. And we know that we cannot integrate cos square x directly, so we will use the double angle formula of cos 2x, which is 2 cos square x minus 1, and from there we'll get cos square x as 1 by 2 plus 1 by 2 cos of 2x. So we will use this, and we got pi, and we'll multiply 0 to pi by 2 and x into this complete thing. We'll get x by 2 plus x by 2 cos 2x, and then dx. Now let's integrate this. I'll write pi outside, Then integration of x by 2 is 1 upon 2 into x square by 2, plus integration of this, we are going to use the integration by part, as 1 by 2 outside and x as the first function, so x into second function is cos 2x, and integration of cos 2x is sin 2x divided by the differentiation of 2x, that is 2, minus integration of differentiation of x, that is 1, into integration of this, that is sin 2x over 2, and we will put the limit afterward from 0 to pi by 2. So let's simplify it further. Pi, it become x square by 4 plus 1 by 4 x sine 2x, and again we'll use the integration, we'll do the integration of this, and integration of this is going to be minus cos 2x upon 2, so and 2 into 2 4, and this 2 will get 8, so 1 upon 8 cos of 2x, limit from 0 to pi by 2. Now we'll substitute this value. Upper limit is pi by 2, so it become pi outside, and pi by 2 square is pi square by 4, and 4 4 is 16, so pi square upon 16, plus pi by 2, if we'll put pi by 2 in this, then it would be 2 into pi by 2, that is pi, sin pi is 0, so it is 0, plus 1 upon 8 cos 2 pi by 2, that is 2 cancel, pi, cos pi is minus 1, minus the lower limit, the x square by 4, x square by 4 means 0 by 4, minus it is 0, so 0, minus cos 0 is 1, so it become only 1 by 8. So altogether we got pi square by 16, this is minus 1 by 8, minus 1 by 8, so it become minus 2 by 8, that is 1 by 4. Now we'll take 16 common outside, so it become pi by 16, and it become pi square minus 4. So pi over 16 is pi over 16 into pi square by 4 is the pi square minus 4 is the answer. I hope that is a unit cube, of course, because it's a volume. So that's it for this video. I hope it is of some help. Let's meet in the next video. Till then, thank you so much.